Hi everyone, sorry for the delay with recording this. So yeah, I wanted to answer your questions. The first question is from Marcos. The question is for real environments, is there a procedure to manage how applications in containers get the service key to access, for example, in S3? Will be covered in the course. We didn't really plan to cover this in the course, but maybe I can quickly talk about this right now. So the typical way you do this, of course, you can get a user, create a user, generate these access keys, and then create environment variables, these AWS environment variables, right, these ones. And then yeah, you can do that is possible, like these environment variables. This is not how it's done usually, and this has problems, right? What if this key is leaked somehow? It's stolen, then anyone who has these keys can use them. Yeah, so this is not a great way. Usually what you do to manage permissions in EC2 in AWS is, so I have an example here. This is the instance I created for this course, MLOps Zoomcamp instance. And when we go here, like there is this tab security, right? And in this security, there is this part, IAM role. So right now I have a role. This is an instance, I think it's called instance profile or something like this. Instance profile role AWS. Right. So this is how you do this for EC2. So the computer, the instance you create, will have this IAM role, and then you can set permissions that you want. So here the permission I have is admin permissions. So I can do anything I want here, which is not good. You shouldn't have this kind of permissions on your EC2, but I don't use a key here, and I cannot lose it because I don't have it. So it's only possible to access this role from that machine. Outside of that machine, it doesn't work. Right? And you can just restrict to what you need, to the permissions you need, to S3, for example, here, and then this EC2 instance will only have these permissions you need. That's one way of doing this. Another way, let's say if you have a container and you deploy this container to Kubernetes. In Kubernetes there is something similar. So I already opened this. So I opened this in incognito mode because this is a paid article, and in Medium. But anyways, here this is how it looks like in Kubernetes. So in Kubernetes, you have AKS, which is a managed cluster, Kubernetes cluster from AWS. And then you say that for, like you can say that this deployment that you have, you should have this role, right? So you create a role, and then I am not super sure exactly how it works, but yeah. So you create this service account, and then if you know Kubernetes, then you say that for your pods, I think it's pod, yeah, you say that like they use this service account. Right, and then they will have this role. All of the pods in your deployment will have this role. So this is how it's typically done in practice. Yeah, so you don't usually use keys. So key is fine if you're just experimenting with this locally, but usually you don't want to have the keys. Okay, I hope that's enough here. So the answer is, will it be covered? We kind of covered it now. Yeah, let me know if you want to know more, but we don't plan to specifically cover it right now in this course. Okay, next one. For the web service you created, a Docker container that serves predict endpoint using Flask. Is this enough for a system that actually is used, that you actually use in prod? Yeah, this is enough. We have many systems like that we do use in prod. Typically you create a Docker container, but then you need to deploy it somewhere. For us at work, we use Kubernetes, so we deploy it to Kubernetes, and then in Kubernetes, you add a few things there, like you collect metrics from this Docker container, from this application, and there are a bunch of other things, but the main thing, the Flask application, is still the same. There are some things around this, but what we showed you in the course is exactly how it looks like in production. Of course, you can replace Flask with FastAPI, for example, or with something else, but the core idea is still the same. There are some specialized frameworks for serving ML models, for example, Kserve. So this is, I think, from for inferencing, for running this like for deploying ML models. And actually this is something we covered in ML Zoomcamp. So this one, the latest, the last one, the last module here is Kserve. You can check it out if you're interested in this. And then in Kserve, you don't write a Flask application. You just say, this is the model I want to deploy, and then it just creates a server for you. Okay, and then there are other things, like for example, Bento ML, which is also like a serving framework. There is Seldon Core, which is another framework. So there are many of them that you can find. Here we just showed you how to do this in Flask, and this can be used in production, but there are other options as well. Can we deploy our web service using EC2, just exposing the endpoint same way we deployed MLFlow tracking server? You technically can. Nobody will stop you from doing this, and it will work. The problem is, what if your EC2 instance cannot handle the traffic you have? What happens then? Then you need to somehow scale it up, and then the traffic stops. You need to scale it down. So in EC2, we have these auto scaling groups. Where they are? These load balancers, auto scaling groups, and you can do this yourself. But usually there are services like Elastic Beanstalk that can do this for you, or ECS, Elastic Container Servers, or EKS that can do this auto scaling for you. So you don't need to worry about thinking how exactly you should do this. It will just happen automatically for you. Of course, you will need to configure it, but you will not need to provision another EC2 instance, install this application there. And then another thing, you SSH to EC2 instance, you start your Flask application, and then something happens and your instance gets rebooted. So how does it automatically restart? So you also need to think about things like this. So it's much more convenient just to take your service, package this to a Docker container, and then deploy it with some container container orchestration service like Kubernetes or this ECS or something like this. So all you need to do now is just to come up with a Docker container, and then there is something else that can take the container and deploy it. And out of the box, you have all this auto scaling and things like this. So like with EC2, it's just too much maintenance, too much admin stuff, like looking after the thing. Okay, this one is quite, I saw this in Slack multiple times, and actually I added this question because this is something I wanted to talk here in this video, because I think many of you are confused. So in the previous videos, in the previous modules, we used Conda, but in this one we use pipen. Why is that? So first of all, pipen is very common for Python in general, for Python backend development. So not just for data science, but in general. So this is like a standard. not standard. There are multiple ways of doing this. So, for example, the most common one is just use venv. Venv Python. So this is the most common way of doing this, right? And it's built in to Python. Then there is pipen, right? And then there is also poetry and also Conda, right? Maybe there is something else as well. There are many of them, but pipen, I think it's officially recommended. But it's also, yeah, it doesn't really matter what you actually use, poetry or pipen. Yeah, so, and I just like pipen more. And the reason, like, there is no real reason why not Conda. So you can use Conda as well. I like pipen more, and it's more common for backend development. Yeah. And also, like, when you want to use Conda, you have to extend a Conda image in Docker, right? So otherwise, I don't think you can do pip install Conda, right? I don't think it actually, well, yeah, it says Conda, Conda install pip. Yeah, I don't think, yeah, it will not give you Conda as standalone application. So you need to, you really need to make sure you extend a Conda, mini Conda image, for example, if you're using Docker. But with pipen, you don't need to worry about this. You just get any Python, you install pipen there, it will install there, and it will work there. Pipen has some other advantages, like, for example, the login mechanism we talked about. Then also dev dependencies. I'm not sure Conda has it. Conda also has advantages. So, for example, in Conda, there are some libraries like numpy from Conda. It has MKL, I think. Yeah, this one. So this one is a faster version of numpy, which exists in Conda but doesn't exist in pipen for pip in general. So, like, if you want to use this one, you have to use Conda, for example. So they have optimized binaries that other, like the usual PyPy, this PyPy, not the one that pip and poetry use. So because Conda has a separate thing called Conda Forge, and then Anaconda also has some sort of repository where it keeps binaries, so Conda uses that. Yeah, so there's not really like the best tool. There are always trade-offs, and in my personal opinion, pipen, I like it more. So that's the main reason. Another thing you asked in Slack so often is how do we use both? So, for example, maybe let me open my terminal. So how do we use both? Because right now I use, if I do which Python, when it opens finally, which Python, this is Python from Anaconda, right? And I can just, let me go to tmp, and I'll create a folder, pip and test, right? And then test. Yeah, so here I just can do pip and install, I don't know, scikit-learn of a specific version, let's say this one, and then I can provide path to Python, and then, yeah, the whole path. So what we did in the videos, we used something like this, but we can also provide path to Python. So, for example, let me open, oops, I don't want this. I just wanted to open this duplicate window. It's the same hotkey as for drawing. Okay, done drawing. Yeah, so in Conda, so if I go to Anaconda, which Python? So I want to go to this location, and then I have some. So if I go to env, I should have some environments. Yes, environments. So I have some environments here. So for example, I have MLFlow environment. I have environment I created for Prefect, and for example, I have this Python 3.8. So let's say I want to use Python 3.8 for my pipen project. So then, oops. Then I need to get the path to binary. I think this is this one. And then I can just say, when I create this thing, I can just say Python like that. And then it will use this specific version of Python. And this is actually a Conda environment. But it will not use the entire Conda environment. It will just use the interpreter, the Python interpreter. So it will not care what exactly is installed in that Conda environment. It will just take the Python executable and it will use it for creating a virtual environment here with this particular library. So let me test it. Now, yeah, it took a bit of time for this to throw this error. So I don't know, on Windows it's kind of funny because I think it probably expects like a proper Windows path. I am not sure. I'll try that. I'm not sure it will work, but just let me quickly. Yeah, I don't want to figure this out right now, but I'll just quickly show you this in VSL. So in VSL, I have Python, which is 3.8, right? But then I also have a Python 3.9 that I installed as a Conda in Conda environment, right? So then I can just go to I'll create a test, pip-env-test, and then I do pip-env install scikit-learn 1.2, and then I'll do Python, which I'll use this the Python from Miniconda. So it will be home. Let me just make it smaller. Or so home. Then it's Miniconda and then Python 3.9. So the Python I have, the version of Python is 3.8, but for creating a virtual environment, I want to use Python 3.9, and it lives in this environment. And again, I don't care what exactly is in this environment. I just want to use this Python interpreter. Then I'll do this, and then it will say, okay, I am using this Python to create a virtual environment. So it will not care what exactly is there. So it will just use this to create a virtual environment. And now, so it's installing the thing. Yeah, almost done. And yeah, so now I do pip-env shell, and now I can do Python B, and it will be that version of Python that we had in Conda. So this is how you can use both Conda and pipenv. And this is typically what you do for your local environment. So this is not something you would then take in Docker, because in Docker you will just do, from Python, and you provide the version of Python, and then yeah, this is just a Python interpreter. So this is not coming from Conda, right? So for local environment, you don't care where the Python interpreter, this Python interpreter, is coming from, whether it's from Conda or from somewhere else. It just cares that it's a Python interpreter of a specific version. Right? So this is how you can use them together. Alternatively, you can use, remember the thing here, it complained it cannot find pipenv. So alternatively, you can use pipenv, and then you don't need Conda. You can just use pipenv and then provide the version of Python. Let me close it. So when you create, so for example, if I now do Python 3.10, it will say, hey, I cannot, yeah, because I think I have, let me do pip-env rm, and then I'll also remove this pip file. Do I have pip file? Okay, I'll also need to remove this one. And now if I do this, it will probably complain that yeah, there is no Python 3.9. Yeah, but now I have two options. I can install pyenv, and then pyenv will download the version of Python I need, or I can just create a Conda environment. Conda create, how does it, I keep forgetting the syntax. Can it show me the help? Yeah, Conda create, is it name? So I'll call it Python 3.10, and yeah, and then Python, I need to specify the version of Python. I think this is the syntax. Let me try. Yeah, let's install it. So now we will get Python 3.9, and I think you got the point, right? So, but I'm just showing it just in case. So we can activate it, but we don't need. All we care is the interpreter that comes with this environment for pipen, as far as pipen goes. So then right now, if we do this, it will still not find it. So we actually need to be explicit and say that this is where it lives. So it's mini conda 3 and Python 3.10 bin Python, and now it will know. Yeah, what's wrong? Maybe it's env. Okay, yeah. So yeah, now it uses this specific version of Python. Okay, I don't know why it doesn't work on Windows, but yeah, whatever. So a question from Marcos. As far as I know, Flask is limited by Python GIL, so threads don't run simultaneously. Are there any other alternatives for web serving not limited by GIL? So it's not a big problem actually that we have this GIL. First of all, when you use GUnicorn, you can specify how many workers you create. GUnicorn workers, like number of workers, and yeah, so you can just create multiple processes that will run in parallel, and then you don't have this GIL restriction there because they are independent processes. So that's one thing. And then there is also like this thing called async IO in Python, where GIL is not such a big issue. I think Flask, does it use async IO? Yeah, it looks like it does. And then FastAPI, I think it uses this. Yeah, so you kind of like with this async IO, you can somehow a bit bypass. You still have this as a limitation, but it allows you to overcome it. But like in my experience, it was never a problem. So the processes, these workers you have in GUnicorn are sufficient, and then like when they are not sufficient, you start scaling up your application. You add more. If we talk about Kubernetes, we'll have more instances, more pods of the same thing running and getting requests and processing them. Yeah, so it's not really that big of a deal. Yeah, other alternatives would be not using Python, using something like Java, for example, but this is not something you would use for machine learning, right? Because in machine learning you have all these nice libraries that you don't have in other languages. In Java you do not really have it. Okay, question from Ron, the last one. In the Flask app we obtain the run ID from the env var. Is there a way to programmatically set the env var? For example, get run ID from MLFlow, set env run. Yes, it is possible. So in MLFlow, I don't think I have it configured, but in MLFlow has CLI, command line interface, and with this command line interface, you can get artifacts. You can actually get So what I'm trying to find is like you can get a run ID for a specific model, so for a specific stage. So for example, you can say, hey, what is the run ID for the model that is currently deployed in staging or production, right? And then it will give you the run ID, and then you can just do something like this, for example, run export run ID, and then here it would be some MLFlow model. I'll just output something like 1, 2, 3, but it will be an MLFlow model, and then now you can see what is inside this run ID. So now it will be just 1, 2, 3, but if it was an MLFlow CLI command that gives you the run ID for a specific model deployed in a specific stage, then you can just get this run ID, and then you do python server.y, and then it will get this run ID and use this run ID. So this could be an option as well. Or another alternative could be, for example, when you build a Docker container, Docker image, then you first talk to MLFlow tracking server to get the run ID, and then you download the model. So you can also download the model using CLI, or you can use S3 CLI, also AWS CLI, to download the model, and then you take this model and you put this in the Docker image, and then the Docker image contains the model, and here you don't care if MLFlow server goes down, you will always have the model in the Docker image. So the build process becomes a bit complicated, and if your model is large, maybe you don't want to put this inside your image, but there are some advantages, like you don't need, you remove this dependency on tracking server, and you also remove the dependency on your S3, right? So on your S3 bucket, so the model is there in your image. Okay, now did I answer this? I think I did. Yeah, so you'll need to look it up. I don't think I can come up with the exact command right now. If I take some time, I'll probably find it. Yeah, but you can also, instead of writing, like doing it with CLI, you can write a simple Python script that just does like fetches the model. I think we did this in module 2, and then you can just do print and this run ID in your Python, and then you can just execute this Python script like this. Python script.py, right? And then you will have your run ID. So there are many different options. Okay, I think that's all for now. So yeah, I hope it was useful, and see you soon. Bye.